Yeah, dear friend, by now we must be tired of writing so many expressions. Let us come back, do some experiment and try to prepare ourselves for some experiment. And what we will discuss in this lecture is how to determine, number one, stick fixed neutral point, number two, this is stick fixed neutral point, stick free neutral point, then stick fixed maneuvering point, and fourth is stick free It is important because so many expressions, so many assumptions were there, right? It's fine. These expressions tells you some or gives you some physical interpretation. Sometimes you have to put a lot of effort in getting all those expressions managed, right? CH alpha, CH delta E, tau, so many variety of symbols. But best way to see what is simple in life is do an experiment and try to find out, experimentally can I find out a stick fixed neutral point, a stick free neutral point, a stick fixed maneuvering point, and a stick free maneuvering point. If you do that, whole world will be assured that whatever you have generated and whatever physics of the situation, if they corroborate, everybody is happy, right? So all those pain of writing big expression goes. So I am working in flight laboratory, I have got aircraft. So whatever expression you give me, my patience will be to that point. Till that time I can write on the blackboard, but my satisfaction would be when I fly the machine, conduct an experiment, find out those parameters and check what theory is telling, how close they are, right? If you plan your experiment correctly, you will find this theory and experiments, they go hand in hand together. If you are not able to plan it properly, a lot of confusion comes, and then somebody will say, oh, what is in theory doesn't work in practice, and all those logics are put, these are all rubbish. Theory gives you the basis, and you should smartly design that experiment, knowing the limitations, and then always, most of the time, you will get good result. Right? So we will now plan for how to find out stick fixed neutral point. How do I develop the physics behind it? Remember, we know that delta E equal to delta E naught plus d delta E by dCl into Cl trim, and we know d delta E by dCl trim was given by minus static margin dCm by dCl by Cm delta E approximately. So, what is neutral point stick fixed? It is that CG location at which dCm by dCl is 0. That is neutral point stick fixed. So, if I now translate this understanding here, since at neutral point dCm by dCl will be 0, dCm by dCl will be 0. So, I can say neutral point is that CG location at which approximately d delta E by dCl trim equal to 0. Why is it approximately? Because this expression is approximate. Remember, we neglected few terms. So now from experimental point of view, it is extremely important what are the approximations you are doing. Right? So what is the message now? If I want to estimate neutral point, I know neutral point is that CG location at which dCm by dCl is 0. So I also know d delta E by dCl trim is given by this. So I translate that definition approximately here, and I say neutral point is that CG location at which, because this man is 0, dCm by dCl is 0, so I say CG location at which d delta E by dCl trim is 0. This concept I use for measuring neutral point stick fixed. So let me write that. Now I have to conduct an experiment. What I do, I take an airplane, I take 3 passengers, and I take the weight in the weighing balance in the hangar, and I estimate, calculate the CG of the airplane with passenger on. Let's say that is CG1. So what is CG1? If this is the airplane, passenger are sitting here and pilot is here. So this is the CG1. Then I go for a cruise. Cruise means I go to an altitude and I maintain unaccelerated flight. So I note down what is the altitude, I note down what is the outside air temperature, I note down what is the V I am cruising with. I am cruising at a V, right? Immediately I should be able to measure what is the elevator deflection given. How do I measure elevator deflection? In aircraft are instrumented like that, experimental aircraft. So this is the elevator part, and as it rotates a potentiometer. Okay? So this is the potentiometer shaft. As this elevator rotates, potentiometer also rotates. This gives you a voltage, and that you can calibrate and get the deflections, right? So we assume that delta is also measured, and I do this experiment for different trim. What is this V? At this V I am maintaining lift equal to weight, so one trim. At this speed I am maintaining lift equal to weight, another trim. So 1, 2, 3, 4, 5 trim I get, and for that I get different delta E. Then what I do? I convert V to CL, which should be equal to 2W by S by rho V square. I can measure the weight of the airplane. I take the weight of the airplane and the ground, passenger, and then I know what is the fuel consumption. I take a stopwatch, how much time is consumed, I subtract that much of fuel, I get the weight, average weight. So I can easily calculate CL. So what I do, I plot delta E versus CL trim. So I will be getting some graph like this, say 5 points I have taken. Why it should be negative slope? You know that d delta E by dCl, sign will be, this is negative, so positive, and this minus sign is negative. So you will get 5 points, say 1, 2, 3, 4, 5 points, join them and mark it. This is for CG1. Now what you do, you come back and take different passengers. Now what you do, you put some passenger, 2 here, 1 here, or maybe 1 here, like different weights, so that you have a different CG. And again you go to altitude, measure the altitude, take the outside air temperature, and while you are cruising at different V, you measure the delta E, elevator deflection, calculate CL, again you plot this. Like that, this is CG2, you will get CG3, you will get CG4. You can go on doing this experiment with different people, different CG location. So this data you have generated. Now what you have to do? You have to find CG location for which d delta E by dCl trim is 0. So what is the way? You take each graph, take their slope. So what is the slope will give you? This is nothing but d delta E by dCl trim for CG1. Similarly, you will have d delta E by dCl trim for CG2. Like this, you will have d delta E by dCl trim for CG3. So So you can have for many points, say CG5. Clear? You are taking slope of this line, that is d delta E by dCl trim, corresponding to this CG1. Second graph you come, d delta E by dCl, the slope of this line, and for CG2. Like this you generate. And obviously this will be all negative. Now you cross plot. Here you put xCg, here you put d delta E by dCl trim, which you have extracted from this graph. And now start plotting for this CG location, CG1, what is this value? Somewhere here, some will come here, and draw them by straight line. And this is the point is what? This is the CG location. I'm plotting xCg. So this is the CG location at which, d delta E by dCl trim is becoming 0. CG location at which d delta E by dCl trim is becoming 0. So this CG location is neutral point stick fixed. Clear? So by definition. So you know how to find neutral point stick fixed to flight data. You have to go to an altitude, you measure the altitude and outside air temperature. These are important to get the density of air. Then you cruise at different trim speed, V1, V2, V3, V4, V5, measure the elevator deflection required for trimming it, convert V into CL, because for CL you need rho, so this outside air temperature and altitude will help. Also V, is indicated airspeed. So all this have done, plot delta E versus CL trim. It will come like this for different CG location, take their slope, cross plot d delta E by dCl trim versus xCg. Okay? xCg. And you extrapolate it, you will get a point on the xCg axis at which d delta E by dCl trim will be 0, and that is by definition is the stick fixed neutral point. So by doing this experiment, you can easily find out the stick fixed neutral point. Clear? Now we want to find out N naught prime, that is the stick free neutral point. How do I find it out, and what is the physics behind it? What is my strategy behind it? I need to understand the physics, then we'll conduct an experiment. Okay, let's see that physics part. If you recall, the stick force expression was half rho v square A plus Ch delta t into delta t minus k W by S Ch delta E by Cm delta E into dCm by dCl free. You are familiar with the Fs expression. Now we divide both sides by Q. So here it is Fs by Q. Here it will become A K A plus Ch delta T into delta T. And here it will be K W by S by half rho V square Ch delta E by Cm delta E into dCm by dCl free. Right? And you could see here W by S by half rho V square is nothing but Cl. I'm sure you are in touch with me. I have divided this term also by half rho V square. So Kw by S divided by half rho V square, Ch delta, Cm delta, or blah blah are there. So this I can write as Fs by Q equal to K A plus Ch delta T into delta T minus K Cl into Ch delta E by Cm delta E into dCm by dCl free. No issues, because for W by S divided by half rho V square nothing but Cl. Now see the trick. Trick is here. What is our aim? We try to find out the stick free neutral point, that is, what is that CG location at which dCm by dCl free is 0. So what is N naught prime? N naught prime is that CG location at which dCm by dCl free is 0. With this, and why we are trying to do like this, if I can somehow manipulate this expression and find an equivalent meaning of that, then I should be able to conduct an experiment with parameters which are measurable, right? Let's see what do I mean. If I now write it like dFs by Q by dCl, what this will become? This will simply become minus K CH delta E by Cm delta E into dCm by dCl free. So what is the meaning now? You see, carefully see this expression. What is our aim? We have to find out CG location at which dCm by dCl free is 0. That means if this is 0, that means at that CG where dCm by dCl free is 0, dFs by Q by dCl is also 0. This is clear? I repeat, the CG which is stick free neutral point at which dCm by dCl is 0, this relationship tells you that means dFs by Q by dCl is also 0. Why we are operating with this term is, please understand, this Fs stick force I can measure using a strain gauge on the stick. Q I can calculate by half rho v square. Cl always I can find 2W by S rho v square, right? Cl trim. These are all easy to measure. I cannot measure dCm by dCl. I cannot measure Cm because at trim Cm will be 0, right? So we do not use this directly, but we use the interpretation and convert into a feasible way which is equivalent and which are having terms or parameters which can be measured. Like here for n naught prime, it is the CG location at which dCm by dCl free is 0, which means n naught is the CG location at which dFs by Q by dCl is 0 as far as experiment is concerned. So I can write to find n naught prime, I can write it is the CG location. This is for experimental purpose, at which dFs by Q by dCl is 0. How do I do the experiment? When I am going for neutral point experiment, I go to an altitude. I again note down altitude. I note down outside air temperature because these are required to measure the density. I trim my airplane for say V1, V2 up to V5. I measure Fs. For every trim, I measure what is the stick force I am applying because my stick will be having strain gauges which can measure the forces through deflections. And now I convert V to Cl. I calculate Fs by Q. But Q is what? You know that Q is half rho V square. That is why we are taking outside air temperature and altitude so that I can get density. V you are getting from airspeed indicator. You need to correct it because that's the indicated airspeed. All those things are finite detail, but conceptually this is available to you. Cl also you can calculate because Cl you know equal to 2W by S by rho V square. Okay? So this information are given to you. Now you plot. What do you do? You are smart now. You plot Fs by Q versus Cl trim for CG1, that is with one configuration. Maybe 2 students you are taking and flying. Next, you take 3 students, another CG2, that is for different points, you are getting Fs by Q from here. For V1, this is the Fs by Q. For V2, this is like this. Those I am plotting for a given CG location. Like that, 3, 4, or 5 I generate. Okay, so I have CG2, CG3, CG4, CG5. Now, simple. What is our aim? What is that CG location at which dFs by Q by dCl is 0? Okay. So what I will do? I will take slope of each line. What the slope will tell me? This is dFs by Q by DCL. That is the slope of each line. So now I will plot DFS by Q by DCL and XCG location here. So for one CG location, I am getting value here, second here, third here, fourth here, fifth here. Join them. What is this point? This point is the XCG location at which DFS by Q by DCL is 0. So this is the CG location which we are talking about, the stick-free neutral point. Clear? DFS by DQ by DCL, which is the slope of each of this line. I'm cross-plotting them with CG, and then I'm extrapolating it, and where it comes to the CG axis, this is the point where it is the CG location at which DFS by Q by DCL is 0, which is nothing but a stick-free neutral point. That is how I measure stick-free neutral point. Clear? Now, the two more neutral points we need to find out, so let us finish that also. Now let us find out how can I estimate maneuvering point, both stick-fixed and stick-free. We want to now try to find out experimentally the maneuvering point, both stick-fixed and stick-free. Let us first find out that by definition, the stick-fixed maneuvering point is that CG location at which d delta E by dn is 0, and stick-free maneuvering point is that CG location at which dfs by dn equal to 0. These are two definitions we are aware of. We have to conduct an experiment to find out the CG location at which d delta E by dn is 0 and at which dfs by dn is 0. We know very well now. I can measure elevator deflection. I can measure stick force through strain gauge. What about load factor? In the theory class we have seen, we have given a maneuvering flight in terms of pull-up and also in terms of bank and turn. Right? We will not go for a pull-up, we will go for a bank and turn. When I do a bank and turn or turning flight, then you know n is 1 by cos phi, which we have seen. Right? Let's say L cos phi equal to W. So if this is your airplane, this is the lift, this is the phi. If it is the W, this will be L cos phi. So if L cos phi equal to W, so L by W is equal to 1 by cos phi, which we know L by W is nothing but n load factor. So if I am banking the airplane and making a turn like this and without losing the altitude, because I'm balancing that weight which will try to take the altitude by L cos phi. Okay? So accordingly, I can find out what is the load factor with which I am flying if I take a reading phi bank angle using bank indicator, which is in the cockpit. Okay. For example, I have banked for 30 degrees, then n will be equal to 1 by cos 30. You know value of cos 30, so you know the value of n. So very simple. Delta you know how to measure. N 1 by cos of phi and Fs through stick force through strain gauges. So all measurements are possible. So what do? I go for, what do? I go to an altitude and go for a turn with a bank, right? And as usual, I note down the altitude, I note down the outside air temperature, and then I note down what is the V, what is the phi, what is the delta E I am putting, what is the Fs, stick force. These measurements I make. Clear? And as I told you, elevator we measure using a potentiometer and stick force we measure using strain gauges. So if you can visit here, we can show you. Now, I have for different V, I have these sets of value, right? For one batch, I say this corresponds to CG1. I repeat this same experiment for CG2, CG3 as I have been doing for other cases, a different combination. Clear? So I take 2 passenger, I go for a bank turn. I take 3 passenger, so different CG, 4 passenger, different CG, 1 passenger, different CG. Like that for different CG configuration I fly and I generate this data. Let's say this could be 10 degree bank, 15 degree, 20 degree, 30 degree, 45 degree. And measure what is the delta E required, what is the V, and what is the stick force I am getting. So now, if I want to calculate neutral point stick fixed, I know it is the CG location at which d delta E by dn is 0. So what I have to do? Very simple. I will again delta E and n, I will see that for different n, whatever I am measuring in the sense that I am computing using 1 by cos phi, right? So I generate this straight line. This is for CG1, another set for CG2, another set CG3 up to CG5. That is what I am doing. I am for the CG1 combination, one flight, what is the delta E I measured, I put it here, and what is the load factor I am getting because of different bank angle. For 10 degree, some delta E. So for 10 degree means n equal to 1 by cos of 10 degree. So I know the n and what is delta E required. Accordingly, I am plotting them. For different CG, I plot like this. Then what I do? I again take the slope, and then I write d delta E by dn versus xCg. So this slope I put here, another slope, so I join them. So this is the CG location at which d delta E by dn equal to 0. So this is Nm, stick fixed maneuvering point. Clear? Delta E, n from 1 by cos phi. I plot it like this for different CG location, take the slope, cross plot, extrapolate, get stick fixed neutral point. For stick free, what you have to do? You should be smart now. You know, stick free maneuvering point is that CG location, say Nm prime, is that CG location at which dfs by dn equal to 0. There is no problem in that. We have already measured fs through our stick using strain gauges. So I'll plot again fs versus n for different CG location as we have done for delta E. Then I take the slope, I plot dfs by dn versus xCg, and 5-6 point I'll get, join them, and this is the CG location, at which dfs by dn equal to 0. So this is Nm prime. I repeat, we have already measured fs and n I know. So I first plot fs and n for different CG location. I join them, take their slopes. I cross plot their slope corresponding to different CG location. Then I join them, straight line, extrapolate, cut the xCg axis here, and this is the point, that CG location at which dfs by dfn is 0. So that is by definition is stick free maneuvering point. This is the simplest way of calculating a naught prime, Nm and Nm prime. Okay. We'll try to solve some examples, but I thought for completion of this part, I must also give you some flavor how do we do experiments, right? Thank you.